Hello guys, my name is Engineer Alide. I want to discuss vector and I want you to sit back and enjoy this topic. Now, before we talk about vector, there is what we call scalar, and scalar is a physical quantity that has only magnitude but no direction. So, in other words, we can say a scalar quantity is a quantity that has magnitude but no direction. A good example of a scalar quantity is mass, time, temperature, volume. You can go and watch my video on examples of scalars and vector. We also say that vector is that which has magnitude, and those magnitude can be represented by the length of the line and direction, which is going to be indicated at the end of the line with an arrow. And also, it can also be what the direction can be represented with an angle. So all this we are going to see in this video. Now, another thing again I want you to understand is that vector, we can have two-dimensional vector, we can have three-dimensional vector. And if you have a two-dimensional vector, how do you know them? Probably you have x and y. Then if it's three-dimensional vector, you have x, y, z. Now, there's what we call a unit vector. I've defined vector for you. I've talked about scalars and what vector quantity. Don't forget that vector quantity have magnitude and direction, and their direction is represented with the length of the line. Then the arrow indicated at the end represent the direction, which can also what represented with their angle. Now, one interesting thing about vector is that you cannot discuss vector without talking about some types of vector. Importantly, those that are important is what I will talk about. Example is what? Is unit vector. Unit vector. Now, unit vector is a vector that has what? Magnitude of what? Of 1. And can be what? Be represented as what? I. I is what we call the unit vector along x-axis. We have J is what? Unit vector along y-axis, and K is what? Unit vector along what? The z-axis. So magnitude, when you take their magnitude, that means I square will be giving us 1. And if you take square root of 1, you are going to have 1. I square is what? To find the magnitude of this I, which is a unit vector along the x-axis. If you take I square, then take square root. I square is 1. That means unit vector square is 1. Then 1, square root of 1 is 1. That's why we say a unit vector is a vector that has magnitude of 1 and can be represented as this I, J, and K. Now, let's say that we have another one called what? Equal vector. Equal vectors. Equal vector what is what? Let me use Excel. Are two vectors that have what? Equal magnitude and direction. Listen to this. They have equal magnitude and direction. If I say A, for instance, is 5 meter what? East, and I say B, vector B is also what? Vector A is 5 meter east, vector B is 5 meter east. I've just said that what? A, vector A is equal to vector B. How? What is the magnitude of vector A? Vector A is 5 meter in magnitude. and east towards the east direction. The arrow will point towards the east in direction. Vector B is 5 meter what? In magnitude, and east pointing east in direction. It means that vector A and vector B are what? Equal. Now, another thing I want to talk about is how do we resolve vector? Because there's another thing you need to know. But before we talk about that, we can have two dimension. Let's say we have what? Vector V is equal to what? Vx, maybe the velocity, anyway, I plus Vyj. This is a two-dimensional vector. This is a two-dimensional what? Vector. So if this is a two-dimensional vector, it means that if you want to resolve a two-dimensional vector, because we say vector is that which has what? Magnitude and what? And direction. Because our focus will be this vector analysis. Don't forget, if you want to find the what? The algebraic, the combined form of a scalar, just what? Combine them by using algebraic rule. I will explain. What I mean by that, if I want to find the displacement or distance of these two vectors, maybe the sum of the two distance covered, I will just sum their 5 meter plus 5 meter, which will give us 10 meter. I will not make use of their what? Their east at all, because distance is a scalar quantity that has only magnitude but does not what? Have a recognized what? Direction. So as such, we are going to have what? 5 meter will be added to 5 meter. Then we get 10 meter distance. But if I want to calculate the displacement, I will consider the east, which will now be what? 10 meter in the east direction. We're going to talk about that. Now, let's go ahead. Now, if you have a two-dimensional vector, like what we have here, to resolve it, we just do what? To find magnitude now of that. What is the magnitude? The magnitude will just be what? Square root of what? Vx squared plus Vy squared. That is how to find magnitude. Square, this is what? The coordinate form of what? The vector form of representing what? Because this is the direction and all these ones are magnitude. So for us to find the magnitude now, just take their what? The Vx squared, this Vx squared, then the Vy squared. You get your magnitude. Take the square root of everything, you get magnitude. How do we get direction? Direction is for theta equal to tan inverse of what? Vy over Vx. Now note, the direction can either be in 4 places. You understand me? 4 places. Now the direction can be what? Can be here. It can be here. It can also be here. It can also be there. Now, the direction can be in this place, there, here. If the direction is in the first quadrant, what does that tell us? How do you know? Your x component will be plus, y component will be plus also. When you have plus plus, you know this angle, the direction will be at the first quadrant between east and north. But if your x component is what? Is minus, and y component is plus, it will be second quadrant. So these are 4 possible position of direction. Then how do you get, if your x component is minus and y component is minus, what do you say? It's going to find itself in its third quadrant. Now if x component is plus and y component is minus, this is minus, and x component is plus, therefore this minus x over there, this plus y, and this minus y. So we are going to consider if x is plus, when you resolve it, the total resolution, and y is minus, that means you are going to consider this as your direction position. This is south, this is west, this is north, and this is east. Now that is how to find the direction. This is for what? Direction, and this is for magnitude. What about three dimension? For you to find what, let's say v vector v or velocity v to vxi, vyj, I know you know what ij and k mean, and what vzk. This is a what? A three-dimensional what? Dimensional vector. Now, how do we find the magnitude? To find magnitude is very easy. What you are going to do is what? Take what? Vx square plus Vy square plus Vz square. And how do you find the direction? The direction is what? Simply what? Vz divided by what? Square root of what? That means tan inverse. The direction will not be what? Tan inverse of what? Vz divided by what? Vs square plus what? Vy square. How do you get it? I will explain that in the next video. So this is direction theta for three-dimensional what? 3D, three-dimensional vector. Now, having known that now, don't forget that I told you that what? Vector is that which has magnitude and what? Sorry for that. That has magnitude and direction, and that direction is indicated as the arrow at the end of the, or the length of the line, which represents the magnitude. Or it can be an angle that must have a reference point or reference line, and the angle must be measured from the reference line. And don't forget, it must be anti-clockwise. Now, all vectors what angle basically are measured from the what? Positive x-axis, anti-clockwise. Please take note of that. All vector angles, please take note of that. All what? Vectors angle are measured from where? From the positive what? X-axis, anti-clockwise. Anti what? Clockwise. Please take note of that. Counterclockwise. All angles, vector angles are measured from where? From the positive x-axis, anti-clockwise. But all bearing, if I say bearing, all bearing, the bearing of what? Bearing angles, let me put it that way. Bearing angles are what? Are measured from the what? From the north in clockwise direction. This one is what? Counterclockwise what? Direction and anti-clockwise direction. Take note of this one. Vector angles. Let me put it like this. Vector angles. Now, vector angles are measured from the positive x-axis, anti-clockwise, in an anti-clockwise direction. Anti-clockwise direction. While bearing angles are measured from the what? North in clockwise direction. So please take note of that. Now, if you believe that now, which means that our positive x will be our reference word line, then you move all your angles anti-clockwise. The next thing to talk about here, which I want to talk about now, is what? The resolution of vector. How do you resolve vector? Don't want to waste time. How do you resolve your vector? If you are given vector, how do you resolve it? Now, we convert the question given to you in polar form. We convert the question given to you into a polar form. What is a polar form of vector? A polar form of vector is what? When vectors are represented in magnitude and what? And direction. So that means your vector angle will be represented in magnitude first, comma, then the direction. Then the direction is from where? From positive x-axis. Please take note of that. all our direction of a polar form of vector must be what? Measured from the positive x-axis in what? In an anti-clockwise what? Direction. So that means you have your magnitude, then the direction in an anti-clockwise direction. That means the direction of what the angle in direction is the direction, and it must have a reference what? Line measured from the positive x-axis in an anti-clockwise direction, having a magnitude force and followed by direction. Please note that your other forms of vector, there are other forms of vector, but I am interested in what? Or interested in what? In the polar form. I am interested in the what? In converting every vector to polar form, because in that case we can now make our what? If you convert it properly, your x component will be what? Be resolved as cos, while your y component will be resolved as what? Sin theta. Please look over. Your x component will be resolved as cos, while your y component will be resolved as what? As sin, provided this is followed properly. So the magnitude itself cos the angle, then the magnitude itself sin the angle. So this will be what? Our basic knowledge for comprehending what? Or comprehend what? To comprehend what? Resolution of vectors. In order to really to comprehend resolution of vector, just take this and it will be our what? Our final whistle for this particular topic. Now, everything given to us, whether in bearing format, you can take it back to what? To polar form without making a diagram of that bearing. So if you can convert the bearing format to polar form, you can now go by what? Taking the magnitude the cos theta, taking the magnitude sin theta, now multiplying by sin theta. Here angle theta are measured for, is the theta here measured from the what? From the positive x-axis in an anti-clockwise direction. I believe it's clear. So this is the magnitude there. Now let us now see how we can apply it. Let's say we take an example. Let's take an example where you have what? 3 Newton. We have 1 Newton here. We have what? This north, this east. Then we have what? Here is what? 2 Newton. The angle here is 30 and the angle here is 60 degrees. Now we have what? 4 Newton here. 4 Newton, which is what? Here will now be 60 degrees. Here is what? 5 Newton. Then which other angle do we have? First we have here? Nothing. So we are asked to resolve all this. Now I want to resolve this particular diagram in polar form. Then now resolve. When I arrange it in polar form, then I will resolve it. So I want you to follow me as we do that. Now what I'm going to do now is to quickly follow the rules given to you. What is the rule? Convert each of the angles or each of the vectors to polar form. Then ensure the angles are all measured from here. Positive x-axis in an anti-clockwise direction. Once you do that, it makes work more easier for us to solve. Now, don't forget that if I move from here, this is 0 degree. That is the starting point. I move like this. This is 30. That means what? 1 Newton is what? Is 0 degree. Then 3 Newton from the positive x-axis is what? Is 30 degree. Then I move over. Now this angle should be 120 degree, because from this point to this point is 180 angle on a straight line. From here to this place is 120. So if you remove 60 from 180, you have 120 to this point. You must ensure the angles are drawn to touch the force itself applied. So that is what? 2 Newton, 120 degree. The next one is what? You rotate again to touch this man here. So what is this angle here? This place is 30. because this everything here is 90. So 90 minus 60 will give us 30. So 30 plus 180 will give us what? 210. So that is 4 Newton 210 degree. So we have, I think this one is what? Just along what? This is 270 degree. This is 90 plus what? 90, 180 plus what? 90 again is what? 270. So 5 Newton, 270. Looking at this now is now in polar form. The magnitude, this is the m, and this is the theta measured from the positive direction. So if we want to now resolve the word into what? The force along the x component and the force along the y component. Now what I want to do is simply one cos 0 degree, one sine 0 degree, like what I said. So I make 3 cos 0, 3 cos 30, and 3 sine what? 30 degree. Then we'll go to what? 2 cos 120. Don't forget they are in Newton. Then 2 sine 120 degree. Then we have what? 4 cos 210. Then 4 sine 210. Then 5 cos what? 270. 5 sine what? 270. Now, if you do your addition together, I want to have it as what? Minus 0.8660. This will give us minus 3.7679. Confirm it. So that is what we want to have as our answer there for the magnitude there. So you are able to resolve them. Now, if you want to now find the magnitude, this in vector form now, this is our resultant force. And that will be written as what? F R resultant force equal to what? Fxi plus Fyj. And what is our Fxi? Fxi is what? That is what? This is minus 0.8660 plus what? Fy is what? Minus 3.7679 J in vector form. This is the answer in vector form. This is I or J. We can see that as minus 0.8660 x bar. That cap there is already unit vector. Minus 3.7679 y cap. So this will be our what? The resultant vector. But in magnitude now, what will be your answer in magnitude? Now the square root of what? Minus 0.8660 square into like a minus 3.7679 square. So press your calculator. What do you have for that? If you press your calculator, you are supposed to have it as what? 3.8661 Newton. That's what I have as the magnitude. Then what about the direction? The direction now is what we want to solve. Direction, theta. Now, the question I'm going to ask the class. Now, look at the board. The question I'm going to ask you now is this. And I want you to answer me as you are watching. Now, what is the quadrant you think these two will fall in? This is minus x, and this is what? Minus y. According to what we discussed initially. What will be your quadrant? Because number one, we have the what? Minus y here, and we have minus x here. So if I have to look at this particular resolution, the resultant along the x and y, critically, it is in the third quadrant that I'm going to find your direction, which will be here. The direction will be here. So this is west, and this is what? South. So that will be our direction. And how do you find that direction? To find the direction is simply what? Just what? Take what? Tan inverse of what? Fy over fx. Fy over fx. So what will you do with that? Now, you just what? Take what? The fy. What is our fy there? Forget about the minus sign. Tan inverse of what? 3.7679 Divide by Fy, that divide by what? 0.8660 to get our direction. So what will not be our answer? If you press your calculator well, you are supposed to have what? 13, approximately 13 degree. Approximately 13 degree. So if you get 13 degree now, that is your theta, your direction. Here will now be 13 degree. So there can be what? What will be here? Here will now be what? Everything is 90. 90 minus 13 degree will give us what? 77 degree. 77 degree. That's what I want to have. So if you get 77 degree for this other side, which is resting on the south, this one is resting on the west. So we can now say, if it's resting on where, we can say our direction is west, 13 degree what? South. If you want to consider this 13 degree. But if you want to consider 77, we can say south. Look at it. Because it's resting on the south now. Look at the board. You can now say what? 77 degree what? West. You can use any of those two. You can also say, because here is 13, what about from the positive x-axis? If you want to measure the angle direction from the positive x-axis, from here to here is 90. From here to here is 90. That is 180. That means from this place to this place is 180, which is angle on a straight line. Plus 13, what will that be? Will that be what? 13 plus 180 will give us 193 degree from where? Positive x-axis. So we're going to have 193 degree from positive x-axis. Now, somebody can say, what about if I write it as what? 13 degree what? South of west. You are correct for this first one. And somebody else can write this one as what? 77 degree what? West of south. You are also correct. So any of these direction, you are correct. Somebody else can say, okay, this one is below the what? The negative x-axis. If you have another one here, it will have been above the negative x-axis. If you have another one here, here will not be what? Above. This one is above the what? Positive x-axis. Then this one is what? Below the positive what? X-axis. So this one now is 13 degree here is below the negative x-axis. So we can write the answer as what? 13 degree below the what? The negative x what? As this can also be your direction. So any of those directions you pick can actually help you to resolve vector by the direction. So any of these directions that we have picked here is correct. Either 193 from the positive x-axis, or you take what? West 13 degrees south, because 13 is resting on the west, or you take the 177 resting on the south, because this 77 is actually resting on the south, starting from the south. 77 degree what? West is correct. Or you interchange them by introducing off. This W will move to the back, which is what? 13 degrees south of west, or we write it as this one as what? 77 west of south. So we can also write it as 13 degree below the what? Negative x-axis. So these ones are very important, that you know you measure your what? Your x, your angle from the positive x-axis, which means that our reference what? Line is what? Is the positive x-axis, taking what? Anti-clockwise. That means all angles of vector should be measured in an anti-clockwise direction from the positive x-axis. I will end the part 1 here. Please subscribe if you know you enjoyed the video, and watch out for part 2, where we are going to be what? Converting bearing format of question to vector question. Remain blessed. Wisdom is something you must fight to get. Keep watching my video, and those of you that were just watching this video for the first time, or you are just seeing my video for the first time, please subscribe. And those returning viewers, you are highly welcome. Thank you for watching. God bless you. Make sure you like and comment. Thank you.